Hello, you're most welcome. In this video session of today, I will discuss about the principle of homogeneity and its application to find out the dimensional formula for different unknown quantities involved in different equations of physics, right? This is basically the second video of this topic. In the first video, I've discussed in detail what dimensions means and how to find the dimensional formula and dimensions of different physical quantities. If you're watching this video for the first time and if you have not yet watched the first video, that is the first part of it, make sure to watch the first video or else you're not going to understand properly. The link of the first video I will give in description. Alright, so without wasting much time, let's give it a very good beginning. Yes, my name is Bapindas and you're watching eTuition. Let's start now. Alright, the very first topic I will tell you today is principle of homogeneity. Principle of homogeneity. Principle of homogeneity. What is basically principle of homogeneity? I'm telling you in simple words. It only says that only those physical quantities which have same dimensions can be added or subtracted. Okay, is it clear? Only those physical quantities which have the same dimensions can be added or subtracted. Okay, if I give you an example, okay, you just know if these two physical quantities A and B are getting added somewhere or the other. Okay, in some steps of physics, in some steps of simplification or manipulation or in deriving an equation, if these two physical quantities A and B are getting added, then be certain about the fact that A and B must have the same dimensions. A and B must have the same dimensions. A and B must have the same dimensions, or in somewhere else if you come across such thing like x minus y is equal to z, or x plus y is equal to z, if it is even, then be sure that all of x, y and z will have the same dimensions. All right, all of x, y and z will have the same dimension. Yes, will have the same dimensions. There can simply be no exception to this rule, because if this rule is violated somewhere, then that equation of physics will be a dimensionally incorrect equation, and that will not be accepted and taken for granted. Is it clear? So principle of homogeneity is something which is crucial and which has to be obeyed for an equation of physics to be dimensionally correct. All right, let's come to the later portion. In simpler words, I may tell you that the dimensions of all the terms which are written on both sides of a correct equation. Correct means dimensionally correct, right? Correct equation should be same. Is it clear? See, the dimensions of all the terms which are written on both sides of a correct equation should be same. That is what I told you for this equation x minus y is equal to z, because on both sides the quantities which are written, the terms which are written are x, y and z. So the dimensions of all of these three quantities x, y and z have to be same. that is a necessary condition, that is an essential condition for this equation to be correct equation, that is a dimensionally correct equation. Am I clear? Or in some other books you may come across such a statement of the principle of homogeneity. Uh, it is like if the dimensions of LHS, that is left hand side of an equation, are equal to the dimensions of RHS of the equation, then the equation is dimensionally correct. Then the equation is dimensionally correct. Then the equation is dimensionally correct. Dimensionally correct. Is it clear? This is known as homogeneity principle. This is known as homogeneity principle. This is known as the principle of homogeneity or homogeneity principle, or mathematically we can say that the dimensions of LHS will have to be equal to the dimensions of RHS, right? That is how we write the dimensional formula, isn't it? In the first video, okay, told you elaborately that dimensions are written within the box bracket or third bracket. All right, so dimensional formula of LHS is equal to the dimensional formula of RHS, or the dimensions of all the terms which are involved in the LHS of a correct equation is supposed to be equal to the dimensions of all the terms which are involved in the RHS of the same equation. Am I clear? All right, now let us come to some problems and numericals. All right, brief first one I want to make you do, I will do as well. It's given V equal to A plus BT, right, where V equal to velocity, and T equal to the time. Find the dimensions of A and B. Find the dimensions of A and B. That is what the question is. Now, how to approach solving this sum? V equal to A plus BT, it is given. So, we can write V minus A minus BT equal to 0. Alright. So, thus you can write the dimensions of A equal to dimensions of V, velocity, because all these terms must have the same dimension. That is what the principle of homogeneity says, isn't it? Dimensions of V is supposed to be equal to the dimensions of A, which is supposed to be equal to the dimensions of BT as well. So dimensions of V is equal to the dimensions of A is equal to the dimensions of BT, B multiplied by T together. Keep it in mind. Alright, so that's what I'm writing. For finding the dimension of A, I'm writing okay, the equality relation between the first two terms, that is dimensions of A is equal to the dimensions of V. Alright, what is V? V is a velocity. It is given in the question itself, and velocity is nothing but L by T, right, or LT to the power minus 1, LT to the power what, minus 1, or M to the power 0, L to the power 1, and T to the power minus 1, isn't it? So the first part of the answer has come out, that is the dimension of A. For getting the dimension of B, we need to write it dimension of BT. Dimension of BT means dimension of B multiplied by T. What was T? T was time, right? So in place of T, I'm writing the dimension, its dimension T itself, capital T itself, equal to dimension of B, right? Dimensions of B, that is velocity. So dimensions of B multiplied by capital T equal to, what is the dimension of velocity? Tell me. Lt to the power minus 1, isn't it? Lt to the power minus 1. Okay. Then finally dimensions of B is coming out as Lt to the power minus 1 divided by T, that is Lt to the power minus 2, isn't it? Yes, that is what the dimension of B is coming out as. That is, we may write it m to the power 0, L to the power 1, T to the power minus 2. Is it clear? Next, come to the next question. Next one, that is question number 2. In it, it is given that x equal to a plus c by m. Okay, what is x? X is displacement, as it is given in question itself. X is displacement and m is nothing but the mass. All right, we have been asked to find the dimensions of a and c. Find the dimensions of a and c, right? How to do this? You take all the terms to the LHS, left hand side. X minus a minus c by m equal to 0. Okay, thus you can write dimensions of a is equal to the dimensions of x. What is the dimension of x? L, which is displacement, and that is nothing but a length. So the dimensions of a equal to m to the power 0, L to the power 1 and T to the power 0. Alright, and then in a very similar way we can write the dimensions of c by m equal to the dimensions of x, or dimensions of c by dimensions of m. What is m? M is nothing but the mass, right? So that's why I'm writing mass itself here. Dimensions of x, what does that mean? X is displacement, that is length. Okay, from here we are getting dimension of c equal to ml, isn't it? So we can write it as m to the power 1, L to the power 1 and T to the power 0. Is it clear? Yes, that should be the dimension only. Let's come to the next one. 3. It is given that a constant which is mu is equal to a plus b by lambda square. Alright, where what is mu? Mu is nothing but the diffractive index. Mu is nothing but the diffractive index, which is necessarily a dimensionless quantity. That is what I have told you already in the first video. Some dimensionless quantities I have mentioned there, like refractive index, like specific gravity, like strain, change in length per unit length, right? Okay, I told you in the very first video. If you haven't yet watched the video, make sure to watch the first video. Dimensionless quantities, which is dimensionless quantity. And what is lambda? This lambda is wavelength. Lambda is wavelength. What is wavelength? This is indeed a length, nothing but a length, right? So that is what making it a simpler one, mu minus a minus b by lambda square equal to 0. So you can write that dimensions of a, yes, the question is find the dimensions of a and b. Find the dimensions of a and b. Alright, that is the question. I forgot to write it. Dimensions of a, can we write it as equal to the dimensions of mu? What should be the dimension of mu? If any quantity is dimensionless, actually there is a way of writing its dimensional formula, although its dimensions are nothing. That is m to the power 0, l to the power 0 and t to the power 0. Nothing means 0. What are dimensions? Dimensions are the powers to which the fundamental or base quantities are raised in order to get the formula for a required physical quantity, isn't it? So in place of the dimensions of mu, all we can write is m to the power 0, l to the power 0 and t to the power 0. Okay, and this is our first answer. And then we can write dimensions of b by dimensions of lambda square. What is lambda? It is nothing but a length. So in place of dimensions of lambda square, I am writing L square equal to the dimensions of what? That is mu equal to m to the power 0, l to the power 0 and t to the power 0. Okay. So finally all we are left with is dimensions of b is equal to m to the power 0, L square and t to the power 0. Is it clear? Is it clear? I hope it is clear to all of you. After that, so let's do another thing. Question number 4. Find the dimensions of x. Find the dimensions of x if an equation is given. The equation is y equal to tan of xt. Tan of xt. And it is given as well that t is time, when t is time. Okay, what is y actually? What is y? We have been asked to find the dimension of x, but what is y? No single thing has been told about y. Y is unknown. What is y? Unknown. Y is unknown. And that is something we don't need to know here as well, because if we would need to know y in order to find out x, this question is simply meaningless. All right, so here we don't need to understand what y is. All you need to understand is what is xt. What is this xt? Can you tell me what is xt? What is this xt? Xt is nothing but an angle, isn't it? Because you know, tan of an angle is something which makes a sense. It's tan of some angle which is theta, and generally the symbol which we use. Tan of an angle of course has to be there in order to give it a meaning, a sense, right? Tan of an angle which is theta. So xt is nothing but an angle. Angle, I told you, is dimensionless but not a unitless quantity. In the first video, okay, I have told you that there are quantities which are dimensionless but not unitless. Two such examples are given you, angle and solid angle. But there are no such quantities which have dimensions but no units. There are no such quantities. But there are quantities which are dimensionless but having units. One such example is angle. So angle is necessarily a dimensionless thing. So we can write that the dimension of angle is equal to m to the power 0, l to the power 0 and t to the power 0, isn't it? Because you know that is a way of writing the dimensional formula of something which is dimensionless. M to the power 0, l to the power 0 and t to the power 0. And that is why we can write that dimensions of x into Dimensions of t. What is t? It's given right in question itself that t is time. So I'm writing capital T is equal to m to the power 0, L to the power 0 and t to the power 0. So from here it is coming dimension of x is equal to m to the power 0, L to the power 0, t to the power 0 divided by t. So m to the power 0, L to the power 0, t to the power minus 1, isn't it? Yes, and that is the answer actually for the dimensions of x. That is the dimensional formula. Dimensions are 0, 0 and minus 1 on m, L and t. Is it clear? Next, another question number 5. What does it say? P is equal to a to the power r square x. P is equal to a to the power r square x, where r equal to the radius. And what are a and p? A and p are unknown. Alright, that is not given in question. I'm writing for you to understand. A and p are unknown because nothing has been said about a and p. Okay, only the much which has been said is r is equal to the radius, and then we have to find out the dimensions for x. Question is this: find the dimensions of x. Okay, now tell me how to find it out. What is r square x? All we need to know here, all we need to understand here is r square x. What is r square x? R square x is a power. R square x is a power. Okay, the power of a, the power or exponent or index, the power or index of a, right? And we need to know always that a power is always a dimensionless quantity. A power is always dimensionless. Keep this in mind. Have you ever heard like this a to the power 2 kilograms, okay, or 10 to the power 2 seconds, or 5 to the power minus 3 meters? Have you ever heard this kind of things? These just make no sense. No such things can be out there, because a power is always a dimensionless thing. Power can have no dimensions, no units like kg, second or meter. Okay, the things that I have written here, you will never ever come across things like that. The power is always a dimensionless quantity and a unitless quantity. Keep it in mind. Okay, so r square x is necessarily dimensionless. Being a power or index of a, it is dimensionless. Say, are things getting clear? R square x is dimensionless. Okay, so we can write that the dimensions of r square of that into the dimensions of x is equal to m to the power 0, L to the power 0 and t to the power 0, isn't it? Because this is dimensionless. What is r? R is given to be the radius. Radius is nothing but a length. Am I clear? So we can write L square multiplied by dimensions of x equal to m to the power 0, L to the power 0 and t to the power 0. Okay, so from here we are getting dimensions of x as m to the power 0, L to the power 0, t to the power 0 divided by L square, or m to the power 0, L to the power minus 2 and t to the power 0. Is it clear? That is what the dimensional formula of x is, or the dimensions are 0, minus 2 and 0. 0, minus 2 and 0 on m, L and t respectively. Zero, minus 2 and 0 on m, L and t respectively. Let's come to the next one. Question number 6. What does it say? Find the dimensions, a tricky one. Find the dimensions of G gravitational constant, universal gravitational constant. Taking the units of d, that is density, and v, that is velocity. Okay, and work, and w, that is work, as the base units, as the base units instead of those of length, mass and time, instead of those of length, mass and time. All right, a good question indeed. What is G? G is actually universal gravitational constant. Keep it in mind. G is the universal gravitational constant. Universal gravitational constant. So how to find out G? From Newton's law of gravitation. F equal to G into m1 m2 by r square. All right. From here you are getting G is equal to F into r square by m1 m2. Okay. So F is mlt to the power minus 2, r is l square, and m1 m2 is m square. All right. So the dimensional formula we are getting as m to the power minus 1, l to the power plus 3, and t to the power minus 2. Okay, but this cannot be the answer because they have asked us to take the base units as d, v and w, that is density, velocity and work. Okay, so what is density? What is density? D, mass by volume, mass by the volume, that is m by l cube, right? M by l cube, or m l to the power minus 3. What is velocity? Velocity v equal to the displacement per unit time, displacement divided by time. Okay, that is L by T, or Lt to the power minus 1. Okay, and what is work done? What is work done? W equal to force into the displacement, force into the displacement, that is mlt to the power minus 2 into L, or ml square t to the power minus 2. Okay, now we have to assume that the dimensions of d, v and w are x, y and z. All right, that is what we assume here, that is let the dimensions of G be x, y and z on d, v and w. D, that is density, v, that is velocity, and w, that is work done. Okay, let the dimensions of G be x, y and z on d, v and w. Okay, so all we can write, the dimensional formula for capital G, that is gravitational constant, has come out to be m to the power minus 1, l to the power plus 3 and t to the power minus 2. Okay, that is m to the power minus 1, l to the power plus 3 and t to the power minus 2 is equal to capital D to the power x, v to the power y, and w to the power z. Okay, m to the power minus 1, l to the power plus 3, t to the power minus 2 equal to, now put the values of d, v and w. What is d? M l to the power minus 3. Okay, m l to the power minus 3 whole to the power x. What is v? Velocity. L t to the power minus 1 whole to the power y. What is w? M l square t to the power minus 2. M l square t to the power minus 2, that whole to the power z. Okay, we have to equate the indices, equate the powers of the same base. M to the power minus 1, L to the power plus 3, T to the power minus 2 equal to, what are we getting actually? M to the power, here one x and here one z, so m to the power x plus z we are getting. How much is L to the power? L to the power minus 3x here plus y plus 2z, right? So L to the power minus 3x minus a plus y, from this plus y, right, 1 into y, and from this 2z plus 2z. Okay, and what is as a power of t coming here? T to the power of y minus 2z, right, minus y, from this minus 1 into y, from here minus 2 into z, minus 2z. Okay, that is what we are getting from both sides. So now equating powers of the same base, equating the powers of same base, equating powers of the same base, all you can write is x plus z equal to minus 1. Okay, then minus 3x plus y plus 2z equal to 3, then minus y minus 2z equal to minus 2. All right, so solving these three equations, we have to find out the values for x, y and z, which are going to be the answers for this question, right? So now see, from here am I able to write x equal to minus 1 minus z? Yes, of course. Put this value of x in equation 2. Put this value of x in equation 2. This is equation 1, this is equation 2, this is equation 3, right? Now putting x equal to minus 1 minus z in equation 2, what are we getting? Minus 3 into x, in place of x we are writing minus 1 minus z. Okay, plus y plus 2z equal to 3. Then we are getting 3 plus 3z plus y plus 2z equal to 3. 3 are cancelling out from both sides, so we are getting a y plus 5z equal to 0. Okay, let this be equation number 4. And what is equation number 3? Y minus 2z equal to minus 2. If we cancel out minus from both sides, then we are getting y plus 2z equal to plus 2, right? Let this be equation 3 only. Y plus 2z equal to plus 2. Okay, then we subtract cancel out the y's, so we get 3z equal to minus 2 or z equal to minus 2 by 3, right? Now if we put this value of z in any one of 3 or 4, then you can get the value of y also. Now putting z equal to minus 2 by 3 in which equation you want to put, say in equation number 3 I'm putting. In equation number 3 we find the value of y as 2 minus 2 into z. What is z? Minus 2 by 3, right? So that is 2 plus 4 by 3, that is 10 by 3, as it is coming 10 by 3. Okay, so the values of y and z have come out. If we put these values in the first equation, if you put the value of z only in the first equation, value of x will come out, or x equal to minus 1 minus z I've written already. X equal to minus 1 minus z, that is minus 1 minus, what is the value for z, as we got minus 2 by 3, minus 2 by 3. All right, so minus 1 plus 2 by 3. Okay, so minus 3 plus 2 is minus 1 by 3, minus 1 by 3. Okay, so the value of x as we have got minus 1 by 3, value of y as we have got is 10 by 3, value of z as we have got is minus 2 by 3. Okay, so these are the dimensions of g, universal gravitational constant, on density, velocity and work done. Keep it in mind, because these three have to be the base units as per the question, not the length, mass and time. All right, not the so-called fundamental units out there. So the answer has to be written in this way. The dimensional formula for g is like d, that is density, whole to the power x was there, that is whole to the power minus 1 by 3. After that is velocity, whole to the power what, that is y, or 10 by 3. And next thing is w, that is work done, whole to the power z, or minus 2 by 3. That should be the answer to this question. Is it clear? I hope this solution has been clear to you. The last one of today is this question number 7. This is a good question, so let us end the class with this question. The question is like this: find the dimensions of a and b, two constants given in the following equation. What is the equation? I will look at the equation: P plus A by B square. P and V are pressure and volume, right? Multiplied by V minus B. B is volume here as well, is equal to RT. This is actually the rectified or corrected form of ideal gas equation. Okay. P plus A by V square multiplied by V minus B is equal to RT. Alright, so listen to the fact what I told you in stating the principle of homogeneity. What was it? That the terms or quantities having the same dimensional formula can only be added together or subtracted from one another, isn't it? So here have a look at this equation closely, that P has been added to a by v square. So p and a by v square should have the same dimensional formula, isn't it? Yes, it is. And another thing, v and b have been subtracted. B has been subtracted from v. So v, that is volume, and b, small b, which is a constant, should have the same dimensional formula, isn't it? Yes, it is. So that is how we should approach solving this sum. Very simple if the basic concept is clear. That is what I try with a little bit of my ability to make the very basics and fundamentals clear. If you have the concepts very clear to you, then you can easily solve many intricate problems. Even you can deal with varieties of problems with the strength of your conceptions. All right. So the dimensions of a by b square, b is volume, of course b is volume, is equal to dimensions of pressure, the dimensions of p. Okay, so this can be split into dimensions of a by dimensions of v square. V is volume. What is volume? In place of dimensions of volume square, am I able to write L cube? Volume is nothing but L cube, isn't it? Length into breadth into height. These three are actually three different lengths, isn't it? So L cube is the dimensions for volume. L cube whole square, because dimensions of v square is here. Have a look at that. Dimensions of v square, that is dimension of v whole square, and dimension of v is L cube. So dimension of v whole square is L cube whole square, isn't it? What is p? P is dimension of pressure only. What is p? P is pressure. That's what I told you already, right? And what is pressure? Pressure is a thrust per unit area. What is a thrust? A normally acting force. So it is force per unit area. So in dimension of force, am I able to write m l t to the power minus 2? Yes, of course, that is what the dimension of force is, divided by area. Dimension for area is nothing but L square, because area equal to length into breadth. All right. So from here you may easily get the dimensions of A. Dimensions of A is equal to m L t to the power minus 2 divided by L square multiplied by L cube whole square, means L to the power 6. L to the power 6. Okay. So L square and L to the power 6 are cancelled out to give L to the power 4. L into L to the power 4 means L to the power 5. M to the power 1. L to the power 5. T to the power minus 2. Is it clear? Alright. Now let's come to find out the dimensions for B. Dimensions for B I told you should be same as the dimensions of V, that is volume, because B has been subtracted from volume, because two dimensionally same quantities can only be added up together or subtracted from one another, right? Keep it in mind. Two dimensionally same quantities can only be added up together or subtracted from each other. All right. So clearly we can write that the dimensions of B equal to the dimensions of V, that is volume. Okay, volume B, and the dimensions of volume is nothing but L cube. Okay, L cube. So these two are the answers. L cube we can also write in this way: m to the power 0, L to the power 3, and T to the power 0. Okay, so that's all for this session. Dimensional formula and dimensions I had discussed in the part 1 of this video, and in this part I have discussed the principle of homogeneity and its applications in solving numericals and varieties of numericals, right? I hope you have understood it, and the problems, if you have faced any, make sure to write in the comment sections, and keep studying. All the very best.